Now that we know how to simplify radicals and have a concept, Pythagorean theorem, that we can use radicals with, now we're going to talk about multiplying radical expressions. So remember this property, we looked at it before. We said that if we had some number under a radical, we could split that number into its factors, preferably perfect square factors, and give each factor its own radical. We're now going to go the other way. If I'm multiplying two radicals, I can put them together under one radical and then simplify. I have 4 examples, so let's look at what that looks like. On the first one, if I have square root of 15 times square root of 3, using this above property, I'm going to recognize that that's the same thing as the square root of 45. First of all, notice, and I should backtrack a little bit, notice that I couldn't do anything with this because neither 15 nor 3 are perfect squares. Now that I have it together as 45, I can ask myself, does 45 have any perfect squares? Well, it does. 45 is the same thing as 9 times 5, and I know 9 is one of my perfect squares. Therefore, I get the square root of 9 times the square root of 5. I know the square root of 9 is 3. I do not know the square root of 5, so I leave it under the radical. Since 5 doesn't have any other perfect squares in it, I leave it under the radical, and there's my final answer. Looking at example 2, again, I want to simplify. So the first thing I'm going to do is multiply. Since it does not matter what order I multiply, I'm going to go ahead and rearrange this to say 4 times 3 times the square root of 6 times the square root of 12. Well, I know 4 times 3 is 12, and I know 6 times 12 is 72. So now from here, I'm going to ask myself, does 72 have any perfect squares? Most of you would probably say that 72 is 9 times 8, and 9 is a perfect square. Because I'm a little bit more familiar with my perfect squares, I'm going to go ahead and recognize that 72 is the same thing as 36 times 2. That then becomes 12 times the square root of 36 times the square root of 2. I know the square root of 36 is 6, so I'm going to change that to 12 times 6. I do not know what the square root of 2 is. Finally, 12 times 6 is 72, so I get a final answer of 72 times the square root of 2. Looking at my next 2 examples, if you feel like you understand the concept, go ahead and give example 3 a try. If you don't, follow along as I go through example 3 and then make sure and try example 4. With example 3, first thing I'm going to do is I'm going to go ahead and multiply 12 and 8. Since there is nothing to multiply the 6 by, I'm going to leave it out front. 12 times 8 is 96. From here, I'm going to ask myself, does 96 have any perfect squares? And if I try doing 96 divided by 16, I see that works. So I'm going to rewrite this as 6 times the square root of 16 times 6. Please remember that if you are saying, how in the heck am I supposed to know that 96 can be divided by 16? You don't necessarily have to know that. Use your calculator. Try it. 96 divided by 16. See if it works. See if you get a whole number. So now from here, I get 6 times the square root of 16 times the square root of 6, which then, I know the square root of 16 is 4, so I'm going to change that to 6 times 4. I have no idea what the square root of 6 is. 6 times 4 then finishing up is 24. Since 6 does not have any other perfect squares, I'm going to go ahead and leave that as my final answer. If you haven't had a chance yet to try one on your own, please try number 4 before watching me go through it. Okay, on number 4, now that you've had a chance to try it, I'm going to go ahead and say 3 times 5 is 15, since it doesn't matter what order I multiply in. And let me go ahead and write that step out, what I'm doing. I'm saying that because it doesn't matter what order I multiply in, I can multiply my 3 and my 5 first, giving me 15, and square root of 8 times square root of 3 second, giving me 24. Again, I have to ask myself, is square root of 24 in simplest form, or does 24 have perfect squares? Because 24 is divisible by 4, I'm going to rewrite it as square root of 4 times 6, which becomes 15 times the square root of 4 times the square root of 6, which becomes 15 times, I know the square root of 4 is 2, I have no idea what the square root of 6 is, so I leave it. Finishing up, I'm going to go ahead and say 15 times 2 is 30. Because 6 is not a perfect square and does not have any perfect square factors in it, I can go ahead and stop here. Big thing to remember when simplifying radicals, please, please, please make sure that when you break up a radical, that you are breaking it up according to perfect squares. Notice on 24, I know 24 is 8 times 3. I know 24 is 12 times 2. Since none of those are perfect squares, it does not matter. I have to break it into the perfect square. So just make sure you're doing that, and then that's all there is to simplifying radicals. That's 6, a little bit more readable. 6.